Biomechanics Numerical Model by Ewan Cochrane. So the first thing we're going to look at is kinetics and kinematics. So kinetics is forces involved in movement of mass, gravity, weight and force. Whereas kinematics is a change in position. So this is where you look at motion. So there's linear motion, curvilinear motion, angular motion, general motion. So general motion, for example, is when there's more than one type of motion going on. So that could be sprinting or running in basketball. Linear motion is when it is hit straight, so a chest pass when the ball goes flat. And then angular motion or curvilinear motion is when the ball is rotating, for example. So when you get backspin on the ball when you go for a shot. The numerical model then. So what are the positives and negatives of this? So the positives of the numerical model are you can analyze against a professional, so you can compare yourself to always improve. So again, then the next one is can see the best way to improve. So if you look at a professional and you look at your body position in that, say in the basketball when you're going for a layup, you can compare yourself and see where you can change to be more accurate, or where you want to put the ball, so putting it into the top corners of the backboard. Negatives, location, it could be quite difficult to get the size of area. If it's quite a small area, when we were recording we didn't have much space for the camera set up and it couldn't always give accurate results. So numerical models are made when you take so it's when you take into account data, so like how many passes a player did within their sport. So, for example, analysing a basketball player, you may analyse how many passes were made successfully, how many were unsuccessful, how many were long, how many were short, how many were chest, how many were overarm, and all of these can be tallied up and put into percentages, so you can see how successful their pass rate is, how many they do a game. But the few problems is the cost of the equipment. So in able to do this, it would cost a lot of money, and it also takes a lot of time to do. Scalars and vectors. So scalars are values that only has a magnitude, and vectors have magnitude and direction. So an example of this could be scalar is a distance, whereas a vector is displacement. So distance could be you're doing a 100-meter race, so it's oh no, let's do a 400 meters. So you're doing 400 meters race. So overall, you've covered 400 meters, and it only takes into account magnitude. But displacement, on the other hand, it takes into account the magnitude and direction. So you've travelled 400 meters, but you're back at your start position, so you've actually done 0 meters of displacement. Speed and velocity. So speed is actually distance divided by time. That's how it's calculated. The unit for speed is meters per second, because it's how many meters being the unit for distance and seconds for the unit of time. Whereas velocity is a little bit different. It is displacement divided by time. So again, the unit is in meters per second, but it needs a direction. So for example, in basketball, rather than 10 meters per second north, you could say 10 meters per second up court, or 5 meters per second down court, just so it gives a bit of sense direction in that sport. So speed in basketball can be calculated through it's like how long it takes you to travel from one area to another. So you could measure a player's speed getting back up the court to defend, and after the opposition has intercepted a pass, so how quickly they can get back. Velocity may be used in basketball, so you can identify how fast a player is travelling up or down the court, so maybe when they had possession or not. Or another example, the difference if they were winning or losing a game, if that influenced how fast they got back to defend. That could be a good one to look at. Especially if you want to analyse players' performance, you could analyse it against different people and see if it affects them if they're losing, if they travel slower. So looking at distance, how far a player technical difficulties, it started to freeze. Distance and displacement. Distance, the difference from point A to B, as I said, whereas displacement is a difference to an object's initial position to their final position. So for example, taking it away from, well, it could be in basketball, but taking it away, for example, a 40-meter sprint would be 40 meters in distance, but 0 meters displacement, as they are back at the start. If you're doing 20 meters up and 20 meters back, you've got 0 meter displacement. Distance, how far a player has moved throughout a whole game. For example, how many times did they go from each side of the court? So they could have travelled, 1,500 meters in a game. That's quite a lot. Whereas the displacement, a player may run from their own key to the other key and back. The displacement would be 0, as there is no change in their starting position. Acceleration. Oh my, it keeps on freezing. There we go, it's working again. Acceleration. Acceleration is the change in velocity divided by the time. So that could be shown as v minus u divided by t. So this is a different area of focus. So looking at Carl Lewis's 100-meter sprint to calculate acceleration, I did 9.35 minus 5.29, which is his starting velocity minus his change in velocity. So yeah, the change in velocity overall, divided by the interval time of 1.07, which calculates the acceleration of a distance between 10 to 20 meters, which is... oh no, that's just how to work it out. Sorry. What have I done here? Oh, and it gives you... nah, I don't know what I've done. Oh yeah, it gives you an acceleration of 2.8. Just calculate it on my phone. Alright, so the acceleration could be used in basketball and is important as it will give you an advantage to get away from your players and the of the opposing team. So it could be calculated by minusing the end velocity from their initial and dividing it by time. If a player can improve their acceleration, then they can find it easier to make space. So what you can do is you can work on getting different forces from your takeoff and how long it takes you, and that should help you improve your acceleration. So looking at graphs on my data over 20 meters, it's so small. So the top left one is distance, I believe that's speed, the top left one, that's how fast I was traveling over 20 meters. And then the top right one was calculating my acceleration, and then the bottom one's calculating my velocity. So although it's my calculations, taking this into basketball and into a team, you could have everyone's speed, everyone's acceleration, everyone's velocity, and you can compare each other, and basically you can see where your slower players are, and maybe if that's the right position for them, if they're slacking a little bit, whether they can need for improvement. So looking at force. So the first bit we're going to focus on is force is either a push or a pull, and a force is a vector because it takes into account magnitude and direction. So for example, a few forces, there's vertical and horizontal forces, internal and external. The vertical forces, so weight and normal reaction. So weight is force going down, the normal reaction is the force going up. Horizontal forces is friction and air resistance. The internal forces are the muscle contractions, and the external forces is gravity, drag, and applied force. So first of all, we're going to look at force plates. Force plates measure ground reaction force, which is the same as the weight force pushed down. So that's how we can calculate what our force pushed down is, because it's the same as the ground reaction. We can calculate how much force we're pushing down into the ground. So then we're going to look at impulse. Impulse is force times by time. So if you want to create a larger impulse, you could do two things. One could be creating a larger force, so that could be created through momentum, which I'll talk about now. So momentum is mass times velocity. For example, in basketball, if you take a step then jump, you should create a larger force going into the ground, and it should also take a longer time, so therefore your impulse will increase, which is good in basketball because then it means you'll be able to jump higher and get close to the basket, which should make it easier for you to get it in. So the three types, no, I've already explained the three types of motion earlier on, which was angular motion, general motion, and curvilinear motion. And then looking at Newton's three laws, Newton's first law is the law of inertia. Newton's second law is the law of acceleration and deceleration. And Newton's third law is action and reaction force. So action force is, say you throw the basketball against the backboard, the reaction force is going to be the ball hitting back off the backboard, and that's always the same. And acceleration is how quickly the ball travels over a set distance. Alright, we'll move on. Oh no, hang on, sorry. Forces, effects. So there are 5 different effects. This is the change in shape, start moving from a still object, stop moving, accelerate and decelerate. So for example, change in shape, if you throw the ball against the backboard, the ball shall change shape and possibly the backboard as well. Start moving, so say the ball is rolling and you move it, it'll carry on moving due to possibly air resistance in the room. Stop moving, again, this could be down to friction. So say you play, I'm not really too sure, maybe if you're rolling the ball along the floor, I don't know why, it may have just got there, it will eventually stop moving due to the friction on the ball and the ground. Accelerate, so if you throw the ball really fast, the ball should accelerate. And decelerate, if you do a bounce pass, when you throw the ball making the friction on the floor, it should decelerate the ball, so it should slow down. Looking at stability and instability. Stability is how stable something is. For example, a person standing with a ball, the center of mass and location. So the center of mass changes when stance changes. This changes in order to keep more balanced. For example, when jumping in a layup, the center of mass goes forward so you can hold your balance. The line of mass always stays the same. You can increase or reduce stability or instability depending on how far your feet are apart or if you're under pressure, for example. So say you don't want anyone to go past you, you can stand there, and if they run into you, you win the point. So you have a wide stance, you stand pretty firm to the ground. So method of collection data. 2D images are flat even though the human body is 3-dimensional. 3D can be used when applying dots or crosses to the body and linking it to a computer, and that will allow you to pivot and rotate the image that you've got, so it should be 3-dimensional. Digital images are computer generated, and then I'll talk about shutter speed and perspective error. So high shutter speed, straight away, is when you take the photo straight away, so it's really fast, and this means it is not blurry, and the faster it is, the less light gets let in, so therefore the only downside to this, the picture could be darker. To prevent perspective error, you have everyone running on the same line, which allows a reliable result as everyone is the same distance away from the camera, therefore all the angles calculated should be similar. And it allows reliability, which means other people can carry out the test easier and should help them get similar results. This is really good as it means you can collect multiple data and compare amongst your team. And the 1 meter scale from the line, so scales can size up on the camera to allow them to measure the limb size to scale, so how long their legs are when they're jumping and things like that. And lastly, the practical results that we collected based on force and reaction force. I will analyse this in assignment 6.4. Thank you.